This device here is an I2C scanner built with an Arduino Nano. It can detect I2C devices connected to the Arduino. Additionally, these devices are hot swappable, meaning they can be removed on the fly. So if I connect it, we can see that it immediately reports two devices found, and that is this real-time clock and temperature unit. Now it's hot swappable, meaning if I pull out the temperature sensor, it now finds one device, and they can be swapped on the fly. Now I'll put it back in. Two devices found again, and there's a 5-second delay so that you can hot swap these devices. So, how does this bus work? The I2C Bus, also known as I2C, is a communication bus that can control up to 127 devices at a time, with just two pins known as SCL and SDA. It does this using a technique called addressing. In this method, each device is assigned a unique number between 1 and 127. 0 is reserved. Then, every time the controller wants to communicate with a device, it calls on its address. To communicate with a device, this is the sequence used. First, the start condition is sent out. This is essentially just when the SDA line is pulled low just before SCL transitions low. After the start condition, the first 8-bit sequence is sent out. The first 7 bits are the 7-bit address of the desired device, and the final bit is the direction of data transmission. A high signal is indicative of a read operation, while a low signal pertains to a write operation. At the end of the sequence, the master releases the SDA line and waits for the receiver to pull the line low to acknowledge the receiving of the byte. The next 8-bit sequence selects the register within the selected device. This happens in a similar fashion to the previous step, which was selecting the device address. After this byte, another acknowledge sequence is performed. After the acknowledged, data is either read or written from the register, which is determined by the R/W bit that was sent out after the device address. Again, this data is read or written the same way that the device address is transmitted. This data step is repeated as many times as necessary to read or write all the desired data, with an acknowledge sequence after every byte. When the transmission is complete, the master sends out the stop condition signaled by both lines going idle. With this 7-bit addressing, 127 devices can be addressed. Additionally, both lines are always pulled high with resistors so that the devices just have to pull the line low. They don't have the ability to pull the line high. Thank you for watching. I hope you learned how I2C works.